Hi folks, welcome to this new craft meetup. So today we have the pleasure to welcome Alexander, excuse me if I don't pronounce it well, Pushkarev, yeah?
Yeah.
Am I good? Yeah?
Yeah, that's good.
Okay. Yeah, he's here to talk about testing in the world of Agile, DevOps and test automation, just like you can see on the screen. So I think you will enjoy this talk. And just like we said during the opening, let's say it, please keep your question until the end of this session. So maybe you can put it directly on the chat to not forget it. But yeah, there will be plenty of time for Q&A at the end of the session. So no worry about that. Thank you in advance, and floor is yours, Alexander.
Oh, good. Thank you. Yeah, sure. Actually, putting the questions to chat is a very good idea. All right. So, yeah, today we're going to speak about testing and what Agile, DevOps, test automation, and other fancy words mean for testers, and like why I decided to make this presentation, or probably more about what you can expect out of the presentation. Among other things, I like asking questions like when, how, why. And in this particular presentation, what we're going to do, we're going to try to concentrate on two types of questions, like what and why. And I believe that asking questions is extremely important for any tester and developer, but well, essentially for any human being. And this is more about giving an answers to questions that should have been asked, but not necessarily asked, right? And a few words about myself. My name is Alexander Pushkarev. Feel free to call me Alex. If you want to follow me on the internet, those are the aliases I'm using. Here they are: AQA Guy, Senpei, or this Russian stuff. I'm working as a senior software craftsperson at Endurance. So today we are going to start with testing. We also will try to understand what is quality assurance risk. And when we understand that, hopefully, we will understand how test automation, DevOps, and Agile change testing the way we know it. And essentially why I decided to make this presentation. And I've been doing the IT related stuff for I think 15, 16 years now, and 7 of which I was a tester and now I'm a software engineer. So sometimes people, my subscribers on YouTube, for example, they ask me like, does testing have a future as a profession? Well, what they ask about is not, it's like, is testing as an activity going to stay? Because, well, I believe everyone agrees that it will. What they're asking about is it a good enough investment of their time to learn testing in order to become a tester? And I was trying to find some kind of statistics, like what is the demand for testers? And it was very difficult to find a statistics which would be about the whole industry. So I used the statistics from the company I worked for. The reason for that is that I know that like when I was working as a tester at this company, it had almost one-to-one relation between developers and testers. But now, check this out. I just tried to see what kind of open jobs they have. And they have 335 open jobs for testers, including test automation, while they have 2,183 open jobs for software engineering. This data is slightly outdated, but I'm pretty sure it hasn't changed. At least it hasn't changed dramatically. And they have 388 jobs for DevOps. So more for DevOps than for testing, even if we include test automation engineers, and almost tenfold more jobs for software engineering. If you try to compare this to one-to-one relation, you see a trend. So it's not like there is no reasonable assumption that the demand for testing is actually might be dropping. And if you look at this graphically, the difference is even more dramatic. So people ask me, and I believe they ask themselves as well, does test automation replace testing? The test automation is biggest culprit. Those bloody test automation engineers, they just doing our job for us, right? Or maybe that's because we started using DevOps and that kills proper testing. Or maybe that's because agile teams, they don't rely on testing, they don't need testers, and they do all sorts of crazy stuff, and they somehow are able to release without testers. So what's going on? And it was also bugging myself, like what's going on? And I tried to read through different documents, through different statistics, in order to make my own picture of actually what's going on and what I could answer to those questions. And that's essentially my answer in this presentation, and also a paper published on the same topic. So let's start with testing and quality assurance. What is testing? And what we could start with the mainstream definition for testing, which is ISTQB. And ISTQB definition says that testing is all activities, which could be dynamic and static, which are fancy words for running the system, or evaluation system, which is not running. And the goal of those activities is to check if the product satisfies the requirements, to demonstrate that this product is fit for purpose, and to detect defects. So essentially, what testing is doing, according to ISTQB, we determine if the application satisfies requirements. So we do, I don't know, traceability metrics, we check according to requirements, then we do demonstration, we demonstrate that it is working, and then we detect defects. I'm not sure if ordering in this definition matters, but let's say those are the three main things. What is quality assurance? In our industry, testing and quality assurance, they used often interchangeably, and that's not correct. Even if you look at ISTQB, you see that quality assurance have a very different definition from testing. So let's see. TMAP is a very nice organization from Netherlands, if I'm not mistaken, which is doing lots of training and publications on testing. So check this out as well. So what the TMAP is saying, QA is a planned systematic activities needed to provide confidence that the product meets the requirements for quality. The important words here is confidence. And then what says ICQB? Well, slightly different wording, but I would say the same stuff. Activities focused on providing confidence, again, confidence that the quality requirements will be fulfilled. So we have quality requirements and confidence, the main words here. So before we jump into some other assumptions, what is quality? Well, quality is a very difficult thing because there is no objective definition of quality. There is subjective definition of quality. Think about, I don't know, different cars. Which car has more quality? Is it Mercedes or is it, I don't know, Dacia, for example? And even though they cost different things, and one can say that Mercedes has more bells and whistles, because it also depends on money you pay for this. It stops being actually objective. And for people, for example, like me, I have a Dacia. Mercedes has lower quality because I don't want to spend the money on Mercedes, and Dacia just works for me. So it's what I'm trying to say is that the quality is a very subjective thing, but there is an objective thing which is called risk, and risk is a chance that a product will fail in relation to expected impact. So that's what I was saying. What is my expectation? My expectation is that I spend a certain amount of money on a car that will serve me a certain amount of year and will cost me a certain amount on maintenance. That's my expectation. What is risk? If I pay more than that, that's risk. If I pay that amount, but the car breaks more often, and that's why I pay more than that, that's also risk. So risk is identified by two main things, which is probability. How probable that the risk is going to occur? Like how probable that driving on my car has a breakdown in the middle of the road and I'm in the middle of nowhere, like at night with the shower and everything. And then the impact, because if I'm in the middle of the road, the impact is quite big. But if I'm at the nearest maintenance station, the impact is not that big. I'm going to the maintenance station, I'm going to have a nice coffee, my car is going to be repaired, I will spend some money, but I won't kill myself with it, right? So that's risk identified by two things: how probable that the risk is going to happen, and how bad it will be if this risk is happening. And that's where quality and risk are related. Quality assurance is activity which does everything possible to make this risk smaller. By everything, I mean literally everything. Everything to minimize impact and everything to minimize the probability. And just try to think why it's important to take this kind of bird fly overview of things. Let's consider the simplest program, the one which is just prints a hello world. You can say it's a very simple program, but in fact, if it's going to work correctly, depend on lots of things. And I'm just mentioning some of them. Was the program correctly coded? Was it developed properly? Was the requirement about the development given properly? Or if we use the correct compiler or interpreter if we write it in Python? If it's all was done properly, maybe our operating system is flawed, or maybe our drivers are not working, or maybe hardware is not working. So the amount of entropy is huge. And when we think of a software system, it is actually very helpful to think about that from system theory point of view. So what is testing? And there is this very nice paper called Entropy and Software Systems toward a theoretic foundation of software testing. It's really long, like 30 pages or something. This very good scientific report on testing and scientific background on testing. So what they're saying is that testing is activity by doing which we're trying to decrease uncertainty. So we're trying to decrease the probability of problem, right? And the main psychological stuff about testing is that we assume the software is broken. For us, it is wise to consider the worst case entropy. We are starting with probability 1. There is a problem. That's the testing axiom. And if you open different books on testing, that's where they tell like the software is always broken unless proven otherwise. All right, but what it gives us, like we perform experiments with software, we check the software, but how it helps us to decrease uncertainty. And that's where Bayesian probability actually works. That's the Bayesian probability formula. We take in software, we run in software for 10 times, and 10 times we see hello world written. Now we have a reasonable ground to say, if I run it again, there will be hello world. Well, there is no guarantee. We don't have to be mistaken. Well, actually, we must not be mistaken about that. We can't say that the software is not broken. So the whole thing of signing off is actually ridiculous. You can't sign off things because, well, that's not how it works. You can't sign off your work. You can't sign off the bloody thing is going to work, even for the simplest thing. And what you can do is that's what I did. That's experiments that I performed. And that's why I think with some probability that it could possibly work. No more than that. So testing is a risk management technique. We demonstrate that software can work by checking possible states, by assessing different scenarios. And by doing this, we are decreasing the entropy. Essentially, we are showing that the probability is not as big a probability of risk occurring. I mean, it's not as big as it could be. And that's actually a very good thing if you think about that from risk management technique point of view, because let's consider Mercedes again and the Dacia again. So if I go to the shop and there is no Dacia, will I buy Mercedes? No, I won't, because for me, the benefit of the car is not worth it. That's what is also true about testing. Let's say you're going to release a software which, according to your estimation, will give you $1 million in revenue. So would it worth spending more than $1 million on testing it? No, it wouldn't, because at some point, when you try too much on decreasing the probability, risk becomes increasing itself. That's why this particular formula is not called a full formula of risk. It's called basic formula of risk. The full formula is very long, and I don't fully understand this myself. So that's why I'm not going to use this here. So it all has to do with test automation. And that's one of the simplest things, really. What is automation? Automation is something that helps us perform tedious and repetitive tasks or physically challenging tasks. Let's think about creating 1,000 users or probably initiating 1,000,000 of sessions with the application. Doing this manually would be a little bit hard, right? So that's what we do with test automation. According to all the research, test automation is predominantly used for regression testing or for performance testing or for stress testing. And that means that test automation cannot replace testing. It actually is not aiming to replace testing. It's a tool which testers can use to make the life easier. So instead of running 10 tests, you run a script, you drink coffee, everyone is happy. But the downside is that to be able to do this, testers, they need to learn new skills. So that's one part of the story. Another part of the story is that test automation is actually not a real automation. Think about automation on a car factory. That's automation is a real automation because you have a car. With test automation, it's not like this. You don't automate a human touching a keyboard, right? You don't do that. You don't automate a human judging, do I like this product? Is it easy for me to use this product? Like you don't automate, I don't know, things like experience or judgment, or even thinking like, I just don't like this blue color here. So I'm going to go to a different web shop because I don't know, this blue is really sickening. So that's not going to be replaced. And that's, I believe, my answer to testers who are concerned if test automation is going to replace this. No, test automation is a skill by learning which you're going to complement you and make you more valuable. So it's not a threat, it's an opportunity. But some people will have to learn some new skills. That's the way it is. That's the life. So test automation, it has economical nature. It's just our way to save money. And if you learn those skills, it's your way to say your employer, now I worth more, essentially. And that goes to the Agile part of the presentation. What is Agile? Well, there is Agile Manifesto. There is Scrum, there is Kanban, there are lots of stuff in Agile. But from my standpoint, if we take these two quotes, that would be the essence of Agile. So the priority to satisfy the customer through early and continuous delivery of valuable software. That's the priority number 2. At the end of the sprint, we have an increment. So what's happening here? We are creating a new version of a product more frequently. How it works with testing? Well, with traditional testing, it doesn't work very well. Traditional testing doesn't want you to change software because they only started testing this. We don't know if the software is working, and you created a new software. So all our testing, like from 2 weeks ago, doesn't worth a thing because that's a new system already. So testing aims to reduce uncertainty. Agile, on the other hand, welcomes uncertainty. And Agile teams, their goal is to be able to thrive through the uncertainty. And there are a couple of interesting side effects. First side effect is that because the software is released more frequently in a truly agile teams, the uncertainty level is quite high, but that's not the problem because in agile, our answer to this, if we make a buggy software this sprint, we just roll back and next sprint, we will deliver something better. That's the way it is. And by squeezing more releases in some time, the kind of time budget for testing is slower, so smaller. So what I'm trying to say is that indeed, testing in Agile, or let's say traditional testing in Agile, is more challenging, more difficult. which, like, a common answer to this is we need to have more test automation. And that's a tempting thing, but in reality, test automation is a software. You create another software to test the software. So you have a more complex software product. Then you have a very complex test automation tool and regression suite. And if you over rely on test automation as your primary means on speeding up testing activities in an agile environment, you're going to shoot yourself in the foot. So what agile communities offering instead? Well, they're offering things like shift left. What if, instead of asking if we build a right product at the end of the sprint, we start asking our stakeholders, well, hold on a second, what kind of product you want us to build? So lots of activities, they're coming to the left. And now we're starting to use test automation, not as means of changing testing, but as means of driving development. And here we have BDD and TDD. And that's a shift left. It's not testing, it's development, but that's better development, better in the way that you can expect from a software which was developed using DDD or TDD approaches to have less bugs, simply because that most of the bugs appearing in the system, they are lack of understanding versus unexpected side effects. And if you have an expected side effect that will be covered by existing thorough test suite, more likely than not, at least. Or if it's a lack of understanding, by asking questions, you get this understanding. So the other unexpected side effect, old school traditional testers, because they just don't really know how it all works. That's not the way they were taught to do things. They feel more stressed and less appreciated in the agile environment because, well, they were taught to make things controllable, while agile is like you just acknowledge that you can't control everything. So there is only one answer to this. If you want to thrive in this environment, you will need to embrace the change. You will need to learn new skills, among which test automation or DevOps, which we will touch slightly soon. So let's just summarize what I was trying to make an argument about. In agile teams, we have decreased focus on testing and QA per se. And it's not a problem. It's not like people might say that if you do agile properly, you give a right amount of attention to testing, but that's not true. That's simply not true if we think about testing as a way to reduce uncertainty. So it's quality of agile models. They are not reducing uncertainty, they welcome uncertainty. And now that's a message to people who struggle, for example, in agile teams. For example, you're a tester in an agile team and you feel that you don't have enough time for testing, that you're always trying to run ahead of schedule or anything. But that's something that you need to be really direct about. That's the way it is. There's only that much hours, that much time, right? You can't make in like 5 days at 3 months worth of work. So if people, management in this case, they decide to use agile models, that's for them to make a decision and to acknowledge the risk that they're not going to rely on testing, and therefore they have to rely on something else. And on what rely, we will learn very soon. So DevOps. What is DevOps? Well, DevOps is very controversial thing. And there is this nice joke is that if you have a DevOps department, it means you don't do DevOps at all. But essentially, DevOps is about bringing our development closer to operation, or ideally don't have an operation team at all. One of the most DevOps companies in this world, I think, is Amazon, where the developers just doing all everything, and that's great. Essentially, that's really good. I mean, that's just fascinating because they are not failing. And DevOps never intended to be a quality assurance technique. However, things like continuous deployment were things that we consider ready to be released, which are going through the quality gates, getting released, and then production monitoring. So if there is a problem, you see this problem rather sooner than later. They actually becoming a commonly used QA measures, especially in Agile team. And that makes a lot of sense. Why so? Because by being able to fix the problem faster or notice the problem, you decrease in impact. So going back to my car metaphor, I can have an engine breakdown in the middle of nowhere. It's like 100 miles in every direction before the civilization, right? But what if instead of having this problem, I'm sitting in my car in the morning and I know that on the weekend I'm going to go somewhere just to have a nice long ride. And my car tells me, well, something is strange. Maybe you should get me to the technician. And by the way, here is the nearest technician. And I already make an appointment. Wow, my car is still broken. The probability of car being broken is not actually decreasing at all. But my impact is lower. I'm driving my car, the car gets fixed, and for the next months, I can be happy. Next month is going to break again. But because this is not a problem for me, my subjective understanding of quality is not decreasing. And that's what's happening. Like, just think about Chrome or other browsers like Firefox. They're still unstable, as unstable they were like 20 years ago. But what's happening now? Like 20 years ago, when my browser would crash with all 5 of my tabs open there, I lose everything. And I need to reconnect using dial-up modem and all this kind of crap, right? Now, I have all my tabs reloaded. And because my internet is good, it's not a problem for me. The quality hasn't changed, but my perception of quality changed, which means the product is much better. And that's, I believe, where the future lies, where the whole shift left lies, by being able to notice the problem sooner and fix the problem. We are making a very economically wise decisions, because doing actually applying DevOps on any project is way easier than making a robust testing. Testing is extremely difficult stuff, to be honest with you, especially a good testing, thorough testing. And it doesn't matter how good your testing is, you won't be able to catch every problem, because there are some things which you can't think about, just impossible to think, but they will happen. That's where you can't live without DevOps. So it's fair to say that DevOps does not replace testing per se, because it's not working on a probability, but it can be used as a replacement, because it can be used as a quality assurance practice. So for example, let's think we have an application where the initial impact of failure is not big, or where we can make it smaller. And we can use the DevOps practices there, because I don't know, we can push our update because it's mobile phone. What it tells us, especially, it's actually very true for mobile phones, because testing on mobiles is a nightmare, especially with this many different devices. It's almost impossible. You can test some flagman phones, but you can't test every of them. So you rely on DevOps, on your ability to fix problems sooner and to get a feedback sooner. So you add a telemetry, you essentially seeing what's going on in production, and it happens, if you remember this very nice movie, it's not a movie, like advertisement, building a plane while you're flying. That's essentially what's happening. And we do this because we have to fly now. We can't wait until plane is built, because if we do this, someone else is going to grab the market. So in this case, when we can tolerate the impact, DevOps can be a very good QA practice or a basis. So for example, let's think about something where we can't rely only on DevOps, because it's critical software. I don't know, it's healthcare, maybe software for rockets, cars, or anything. If someone would tell me that, I don't know, my car was tested only using DevOps practices, or it wasn't tested, sorry, was the software for this was they were using only DevOps practices, I will be horrified. I will turn off the bloody computer from the car because I know like how risky it can be. But what we could do and what we should do, and they're doing this already, they're adding a telemetry. So your computer, it's recording what's going on. So next time when you get your car to the maintenance, they're reading telemetry and they're learning. So they apply DevOps practices. They can't connect your car to computer or to internet, at least yet. But what they could do is to gather data offline and try to analyze this. And based on this data, on different readings from different kind of sensors, they can assume, okay, though, so that's kind of failure we can expect. So, for example, like what the worst case scenario if you have a car broken and you the technician now, the worst case scenario if they don't have a repairment parts for you. But if there is a repairment part and car can be fixed like in a couple of hours, that's all right. So they're trying to adjust. But in addition to this, they're also going to do robust testing, because even though they're trying to adjust, it's still not enough. But what I'm trying to say though, because DevOps practices, they're usually cheaper than right and like robust testing, it makes sense economically to start with shift left and DevOps before you use a proper testing. And that makes sense to do psychologically, because people who used to work in a traditional waterfall environment, as soon as they see tester, they feel, okay, I'm done with quality. Here is the person who is going to look after quality. And that's not because developers are being bad people. It's actually very, not a smart, but very logical thing to do, because you have lots of stuff to work on and you need to prioritize. And if there is someone who is looking after quality and they are qualified to do this, it makes sense for you to let them do it. But because it's software is not like car, you don't make car like with cars. You make car, you can verify that the car is working and you can sell car. In software, it's not like this. In software, you are again building while flying. So that's why when you stop caring about quality, you're going to fall, because you can't wait for testers to notice that you don't have wings anymore, right? You're going to fall. So here we go into a conclusion. So from psychology, from system level point of view, and from scientific point of view, indeed, software is broken unless proven otherwise. And the goal of testing is to decrease the uncertainty. And the goal of Agile and DevOps is to decrease the impact of failure. They both work on risk, but they do it differently. And reality, because the economy is, well, we can't wait for the software to be developed for years now. We have to move fast. So that's why the reliance on testing is decreasing. It's not decreasing everywhere, I must tell you. In some regulated areas, you still see a proper waterfall process. And it's, I mean, by no means I'm trying to say that waterfall is bad. Waterfall is actually very good and understandable process if it's used in the right circumstances. But the long story short, in our reality, we can't use waterfall because we are not only building a plane while we fly, we don't know where we are flying. And that leads us to not rely on testing that much. But testing is just another risk management technique. While test automation is not even a QA activity, it's optimization technique. And BDD and TDD, the shift left part, they are not even test automation, they are ways of development. So just a kind of final words here. When you go out of this webinar, it would be really good for you to think and maybe answer yourself, would you prefer a software with no bugs, but which doesn't have the features that we need? Or maybe you want a reasonably buggy software which is cheap, free, but it does have features that you want, right? Or maybe You want a software with no bugs, but which you cannot afford. And try to think about not only software, about cars, about everything, because software is not unique in this regard. The only unique thing about software is not the way we see quality, but about the way we create quality. And that's why we should change the way we build software rather than the way we test software. So that was it, essentially. You can try to, I'm not sure if this presentation will be shared, but make a screenshot, photo. That's the links how you can get in touch if you want. And now I believe I should be able to answer all the questions that I have. So I'm probably going to open the chat.
Yeah, thank you, Alex. Thank you for let's say this questioning at the end, because yeah, I like the way you explain it, the way you ask your questions. And yeah, we can ask ourselves, what is, from our point of view, what is quality?
Could I link the YouTube channel here, please? Yes, I can. Let me. Yeah, that's right now. It's really empty, but it's going to change soon. Let me just copy this for you.
For the others, do you have any questions for Alex?
There is a fun question. Let me see. It allows junior members to, oh, it's not a question, it's a comment.
Yeah, it's a comment, yeah.
Yeah, so yeah, I just sent a link to the YouTube channel. If there are no questions, thank you very much for your time. And yeah, it was a pleasure being with you.
I have one question, if there is none.
Yeah, go on.
How do you convince people in companies that but just like you explained, I like your definition, but DevOps is not it's not a team, it's not it's not something that you can clap in your fingers and say, okay, we are DevOps. How do you convince people that it's not like this? Because yeah, it requires a lot of cultural it's cultural transformation at the end, and it's always hard to change this kind of aspect in companies. And just like you explained, for in a lot of companies that I worked with, yeah, they have a DevOps team. For me, it doesn't mean anything, but okay. And I don't know how to convince them, but maybe it's not maybe it's one step, but it's not the end to have this kind of teams. And I don't know how to do that, to be honest.
I don't either, to be honest with you. It's kind of really difficult because that's a cultural thing. If people just used to think in the definitions of teams and throw in responsibilities from one way to another, they just won't change, no matter what you do. And because the change sometimes is disruptive, or it appears disruptive, not only they are not going to listen, sometimes they're going to push back. And it also makes sense because in a short term, maybe a couple of months, if you try to change the way team works to be to really embrace DevOps, the velocity could slow down a lot because, or at least the way they measure velocity will slow down, especially in a very old-fashioned teams where there is different velocity markers for development, for testing, and for DevOps teams. In this case, if you go to developers and tell them, well, actually, you're supposed to do some kind of DevOps activities, they will probably beat you, because if they do, they perceived velocity will drop. So it's not like you can do this. What you could do, and that's very difficult because it's kind of it's not about DevOps per se. It's about how do I change the dominating culture of organization, which is challenging.
Yeah.
So what you could do, you could create a small enclave. So you could find a people who thinks like you, and you could try to build your own team if you have proper authority or power for this, or at least share practices. But I wish I could say that there are some good practices and good answers, or maybe convincing papers that you can share, and people will magically change their opinion and the way they're working for ages. But in my experience, it's just not happening. The change is painful, and people who drive change are not always appreciated. And yeah, it's going to be difficult. And sometimes the best way to change the company is to change the company. I mean, to go to another company. So yeah, and yeah, that's again, if you really want to know how to change companies, it's probably better to ask people who are really good at sociology of little groups. There is a whole body of sociology called sociology of groups and of little groups. A company is considered a little group in this case, and it's so interesting and so challenging. I believe if you know the answer, many people will say like, oh, it just doesn't worth it. I'm not doing this. So yeah, that's sad. I wish I had a more optimistic answer, but that's all I got.
No, but I totally agree with you. So yeah, I have worked in many companies and still work in a lot of companies because I'm freelance. And yeah, it's always the same, just like you said. Change the culture is the other part of what we do, and yeah, it's not that easy. But I've read plenty of books regarding it, and yeah, it's based on sociology and psychological aspect of human beings, everything related to biases as well. So there are plenty of good stuff on it, but yeah, there is no magic recipes for that. Yeah, that's for sure.
Yeah, and again, because I believe unless your job is to be agile coach or someone who is doing things like that, you probably won't be able to dedicate enough time to learn those things. Because what's happening, sometimes you assigned as a developer on a project and you want to change things, but it's kind of they are not expecting you to do things, and you could probably learn how to do that. I mean, that's the skill. You can learn this, but you will do it at the expense of learning other skills, and that's what I was trying to say. That do you think it's worth it? And for every person, the answer will be different, and that's where we need better coaches, I think, because the coaches, some coaches that I worked with, they just seemed it as like another way of earning money. They weren't actually qualified for the job. Let's say.
Yeah. We have a question from Mike.
No, it's
Michael.
kind of I got to go. Think a lot, so that's
No, but
unfortunately.
just behind it.
Oh, okay. In a competitive environment, one good way to show people better ways is simply to win the competition. Then they get interested in how you're doing it. That curiosity and the motivation is extremely hard to change things inside a company team because of habits and culture. Well, that's indeed is a good thing, especially in a companies which have a cooperative competitive environment. Because in a truly competitive environment, like some companies where there is quotas of people have to be fired, right? If you try to win a competition by showing some dark magic of Agile, you're going to have lots of people who will be happy to see you fail, and they will do everything that they could in order to make you fail. It's kind of that's another thing where there is a Nash equilibrium of people. Like if we all do bad, we are not all getting fired, right? And if there is someone who is doing good, well, this bloody bastard is making all us look bad. So that's again, it's so difficult, and there is no. When you join another organization, you might think that, okay, I've seen this before. I might possibly know the way they think, but no, you don't. They're all different. So yeah. All right, guys. I also have to go soon.
Yeah.
Thank you very much.
Thank you very much, Alex. Thank you for your time.
Oh, go hold on a second. There is a very interesting question regarding the shooting yourself in the foot with test automation. That's a very good one. Well, there are many ways to shoot yourself in the foot with test automation. First of all is that we need to remember that when we spend time or money on something, let it be test automation or buying new marketing, we are setting our priorities. So one way to shoot yourself in the foot with test automation is to spend more time on test automation than you should be spending on something else. Like, for example, asking yourself, is a particular feature worth implementing at all? Or implementing some other feature? And because there is just as many people here in the room, depending on the team setup, like there is limited amount of resources. By doing test automation, you literally say no to something else. And that's the first way to shoot yourself in the leg. The second way, and that's the most troublesome, is when you do test automation and everything works great. Like you see a very fast feedback loop, your quality is increasing, and all of a sudden, your quality starts to decrease. Essentially, you see that test automation is not catching bugs, which could happen because of the pesticide paradox, which is saying like, because test automation, people, when they run through test cases, they usually deviate, make small fluctuations, even involuntarily. So they just not following the same route. Like think about minefield, right? Because you're wandering from here and there, you find more mines. But test automations like robot, it goes only here and there without randomization. And if you add randomization to test automation, you are risking to have lots of flaky tests. So people avoid randomization in test automation as much as they could. And what happens, you have more tests, you spend lots of time on tests, but the quality is not changing, or it's actually getting worse. There is a third way to shoot yourself in the leg with test automation, which is, let me try to think about the proper example for the third way. Yeah, okay, so this third way of test automation, shooting yourself, is connected to this second, but it's slightly different. Let's say, okay, the same is true. You invested in test automation, it's fast, it gives you excellent feedback. And management makes a decision. So we don't need testers anymore. Let's just cut off testers' jobs. You cut testers' jobs. And you forget that for test automation, someone actually has to think about what to test. So this thinking part is getting cut, which leads to the quality of test automation dropping dramatically, and again, increasing bugs. Or something else can happen, which is the test automation system becomes so complex and so flaky, so it's impossible to maintain. And you run tests because you have 2,000 of automated tests. It takes you 12 hours to run and 12 hours to understand the meaning of the 12 hours run, because there are like 200 of failing tests, because things are flaky, because there are some new features. So there are many ways to shoot yourself in the leg with test automation. This kind of the one that I mentioned, these are the most common. Yeah. Right. Good.
Okay. Thanks, Michael. Thank you, Alex, for this great session. I hope you learned something in the participants. I hope you have some question in mind, because yeah, just like you said, it was based on questioning. So I think it can trigger some questions in our head. I hope so.
Yeah, absolutely. So you're asking yourself the questions. That's a great thing to do. So
Yeah.
thank you guys. It was a pleasure being with you. See you
Sure,
later
maybe.
then.
Yeah, see you later. And guys, if you want to register for the next session, it will be on the 24th, and the next session will be about sustainable IT. So what kind of stuff you can do to create more sustainable stuff for our planet at the end. So it will be really great. So it will be the director of the Belgian Sustainable IT Institute. So yeah, I hope you will enjoy this session as well. Thank you again, Alex.
Yeah, see you.
See you. Yeah, thanks. Bye.
Goodbye.